All right, this is going to be the formative, chapter 7 formative video, and you should be writing what I'm writing as usual. You should have your checks and X's or your notes out for your checks and X's so that you can keep track of what targets specifically you're missing and getting correct. Okay? So the first one, these first two are actually going to be, learning target number 8. Now, learning target number 8, we actually didn't do a learning video for learning target 8, but the reason why is because we kind of do this in learning target 1. So that's why we didn't do a video on it, but still I want you to put your check or your X in learning target 8. So, Roberto has been playing piano 8 times as many years as his brother Felix has. Okay? It says use F, so we're using the variable F to represent Felix. Write an algebraic expression for the number of years that Roberto has been playing piano. So, I mean, it kind of gives it away because it says that word right there. We know that it's going to be the 8 times the amount of years that Felix has been playing the piano. The thing you have to realize is, well, how do you write it? Because I'm not going to accept 100 different ways to write this. Over here, I'm going to do the wrong ones. So that is right there showing F times 8. That is showing 8 times F. This would be showing 8 parenthesis F. That would also be showing, and then F8, anything like that. Those will not be accepted. Even though they're technically showing multiplication of F and 8, I'm only going to accept one answer, and that is when we actually put the number that we're multiplying by, the coefficient, directly in front of the variable. So I will only accept if you put 8F as your answer here. Okay, so go ahead and give yourself a check or an X on that one. Like I said, if you wrote 8 times F or 8XF or any of these, those are wrong. You need to make a note that this is how we show multiplication of a number in a variable. Okay, now that you know that if we know how long Felix has been playing, we can just plug it in for F. Well, in part 2 here, number 2, it says, if Felix has been playing piano for 2 years, how many years has Roberto been playing? So he's only been playing for 2 years, so think about this. What we're going to do is we're just going to take this, we're going to take this 2, and we're just going to substitute it in here for that F. So if we were rewriting it, we would write it as 8F, and then we would put 8 times 2 because we're substituting the 2 in there for Felix because we're talking about Felix, and we would find that Roberto must have been playing for 16 years. No, you didn't have to have the label. If you just simply wrote 16, that is fine. If you didn't have work, that's okay too. I'm okay on this one if you just put 16. Technically, I would want you to do it this way because you should always turn the algebraic expression into a numeric and then find your answer. Okay, so make sure you give yourself a check or an X on those ones. Let me go down here to number 3 now, 3 and 4. These are going to be learning target number 6. Sorry, didn't mean to bring that back up. So these are going to be learning target number 6. Okay, this is where we are stating, I'm sorry, it's not right. I apologize. It's going to be learning target number 7. Apologize for that. Learning target number 7, we are stating whether or not the expressions are equivalent or not. So I'm going to get my highlighter tool ready here because that's what I'm going to be using because that's how I taught you to do it. So hopefully you're realizing that these are 2 different expressions right there. By the way, you did have to show the work that I'm about to show. If you didn't, it is wrong. Okay, if you simply just put in A for yes or B for no, it's wrong. It doesn't count. So you may as well mark it wrong. It'll be wrong on the summative as well. Okay, so we know that we have an expression here, and we know that we can always simplify expressions if there are like terms in them. Now remember, like terms, when it's a variable term, is anything that has the same variable. So since we have 2 S's, and I like to call them sharks, so we'll say here I have 2 sharks and here I have 7 sharks, I can take those sharks and I can put them together to now give me 9 sharks. Bring down my plus. Now, is there anything I can combine with 3? Hopefully you're thinking no, there isn't. So right there, that is in simplest form. Just to make sure, I'm just going to do this just to make sure that nobody did it. I have some people still are doing 9s plus 3 and then getting 12s. Just understand that is absolutely incorrect. Okay? You cannot combine this term and this term because, first of all, that would be breaking PEMDAS. You would be then adding 9 and 3 before you multiply. So this is as far as you can go. That is the most simplified version of that expression. But just remember, they're both equivalent. So let's do the same thing over here. Let's look for like terms first. I see 4 sharks here. I see 5 sharks here. Change colors. Now we're going to see a constant of 2. Notice the words I'm using, constant and coefficient and like terms and all the terms you're hearing. I'm trying to use them. Okay, so I have these like terms of these sharks again. So I have 4 sharks and 5 sharks. That is going to give me 9 sharks. 4 plus 5 is 9. Bring down plus. I know that constants can also be combined because they are also like terms. Constants are always like terms, which is going to be 3. That is the most simplified version. So you just ask yourself, are they the same? Yes, they are absolutely the same. So this would be A. Yes, they are equivalent. Now, the other way you could have done this, if you wanted to, is you actually could have taken and say, well, I'm just going to take S equals 2 and plug it in for them. If you did that, which I wouldn't advise you to do that, but you could do that, if you did it, and just as long as you showed all your work on how, when you plug 2 in there and what you get for both of them, then you'll be good. Okay. Number 4, same thing here. We're doing the exact same skill. So we have 5 sharks here. We have 1 shark there, and we have 6 sharks there. Okay. Change colors. We'll see if there are anything like the constants. And I see, yep, there's a constant of 3. There's a constant of 3. So right now, I know that anything that's in orange right there, I think I can combine. So I have 5 sharks and 1 shark. That makes 6 sharks. I have 6 sharks and 6 sharks. That makes 12 sharks. Plus, I have 3 and 3. Those are just constants. They can also be combined to make 6. Let's go over to the other one. I have 10 sharks and 2 sharks. And then I don't have any other terms to go with 6. So I can put these together to give me 12 sharks plus 6. Are they equivalent to one another? Yes, they are. The answer is A. So just like the other one, if you came down and said, well, what if S equals 3 or 4 or 5 or whatever, as long as you showed your work and you got that they were equal, that is fine. Okay? All right, number 5. Now, there's going to be some work required here on number 5. Okay, this is going to be learning target number 3. Okay? All right, I'm going to go a little slower on this one because I want to make sure we got it all down, because this is one of these that throws you. If you don't have the following work, it is wrong. Your work needs to match mine. Now, right away, when I look at this algebraic expression, I see that there's a numerator and a denominator. I see that there are fractions. Okay. Now, we know that really all this big line here means is division in this line here. But if you'll remember from when we did this target, I said the first thing you should do is put any expression in the numerator or denominator of a fraction. You have to put it in parentheses. Okay, so you had to do that. Now, remember the first step to doing any evaluating of an expression, you have to turn, and you might want to write this if you didn't do it, turn the algebraic expression into a numeric expression. Okay? So that's the very, 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 very first thing that you need to do after you put those parentheses on. So now what we're going to do is I'm not going to do any math problem. I'm not doing any adding. I'm not doing any subtracting or multiplying or dividing. I am just going to rewrite this. So I'm going to rewrite it as parenthesis 15 minus 6, because I know that x equals 6 according to that right there. Now, if you left it as a fraction over 9, that is fine. I'm going to turn it into this. Okay, plus parenthesis 4 times 6 plus 3 over 3. Okay. Now I'm hoping some of you are writing PEMDAS. Not everybody needs to, but I think it's still something that we should consider because it does help you. Okay. So we are going to do parentheses first. So I see there are 2 sets of parentheses. We're just going to start on the left. So I'm going to do these first. That's going to give me 9. I can get rid of the parentheses now because it's down to one number. So it's 9 divided by 9 plus, I kind of broke my own rule here. I said I wasn't going to do fractions. Like I said, you can do it both ways. It doesn't really matter. I don't really care how you did it. I just think that it doesn't matter. Okay, so we know it's going to be 4 times 6 plus 3 divided by 3. Now we're going to go into these parentheses, right, everybody? So we are going inside these parentheses. We're still in this step here, but now we have that little mini PEMDAS. So when you go inside parentheses, the first thing you look for is more parentheses. So I got to do multiplication or there are no parentheses, there are no exponents. We do multiplication first, so that's 24. Now, just remember, I have to leave the parentheses on there until I get it to one number. So I bring down everything, 9 divided by 9 plus. Now I'm ready to finish these parentheses off here. It's going to be 24 plus 3 is 27. Bring down everything, 27 divided by 3 there. 9 divided by 9 plus 27. I'm finally done with my mini PEMDAS, and I'm finally done with the big PEMDAS. Okay, now we go on to exponents. Are there any exponents? No, there are not in this one. Multiplication or division. Remember, that happens left to right. So are we going to do this one or this one first? We are going to do this one. So that's going to become 1 plus 27 divided by 3. And I'm going to bring this over here. 1 plus 27 divided by 3. Okay. Now I'm still on the multiplication or division step because it's still there. That's going to be 9. And then 1 plus 9. I'm finally done with the multiplication or division step. Now I will go on to just adding because there's only one step left. And there's where I get 10. So these steps need to be here. If you skip steps, if you did more than one step in a line, wrong. Okay, I've made it very clear that this is how I want it done. Okay, so I want this answer and I want it to be done like this, okay? All right. So give yourself a checker next on learning target 3 for that one. Okay. Here we have another, this is just a simplifying the numeric expression question because there are no variables to do anything to. So first thing we're going to do is we're just going to write PEMDAS up here, right up here in the black up here, PEMDAS. Okay, and we are going to do parentheses first. So we go inside parentheses. Now remember, when you go inside parentheses, you have a little mini PEMDAS. And I'm just going to write a squiggle because it's small. But what that means is you can't go ahead and just say, well, I'm going to add 3 and 7 and then make it 10 squared or 10 to the second power. You can't do that. You have to follow that mini PEMDAS. So when you go inside parentheses, you look for more parentheses. There aren't any. Then you're going to look for exponents. So we're going to do these exponents first inside there, and that's going to be 49, not 14. I have some people trying to tell me that equals 14. No, 7 times 7. Okay, you may want to write that just so you have it. Now I'm ready to bring down everything. So 4, parenthesis, 3 plus 49 plus 3. I'm going to finish my parentheses. That's 52. Remember, when a number is touching a parentheses like that, we are going to have to multiply. Plus 3. Okay. Now we're on our PEMDAS. We're done with the parentheses. There weren't any exponents. Some of you might be saying, well, yeah, there are exponents right there. Well, that was just inside parentheses. That was for mini PEMDAS. But there are no exponents other than those. Now we're on to multiplication or division. I can clearly see that there is definitely some there. That's 208. Then you bring down 208 plus 3. We're done with multiplication or division. Now we are going to finish it by adding that, which is where we would get 211. Okay. All right. Let's go down here. Scooch this up. Go to number 7 now. Okay, number 7. Now I had some people asking me, what are those things? Well, those are just fancy parentheses called brackets. You've seen me do them every time I do a fake ratio or anything. I always put the brackets. It's just so that it doesn't become like parenthesis like that. That's the only reason, because it just looks kind of funny when you do it that way. But when you follow PEMDAS, watch how I do this. You're following PEMDAS, so the first thing I see, I work my way left to right. So the first thing I see is these fancy parentheses called brackets. Well, when I go inside those brackets, I know that I have to do a mini PEMDAS. Okay? So when I go inside of there, the first thing I'm going to see is I'm going to see more parentheses. So I had to do the innermost parentheses first. So 8 plus 2 is 10. Now I'm going to bring down everything, 10 minus. Now, I got rid of these parentheses here that I have in teal, right? But do I have to keep the orange ones? Hopefully you're all thinking absolutely yes, because you do have to keep them. Okay, you have to keep those. You could turn them into parentheses or leave them as brackets, doesn't matter. Now I'm going to finish those parentheses. 10 minus 10 is definitely 0. Okay, I'm finally done with parentheses. Just like parentheses, that right there, that's multiplication. Okay. and then there are no exponents, and then multiplication is the only thing we have left, and we know anything times 0 is 0, so our answer is 0. Okay? So you had to have all those steps on 6 and 7. By the way, I forgot the learning targets. I know you're probably all yelling at the screen right now. This is learning target number 2. This is learning target number 2. Okay? All right. The next 3 are going to be learning target number 1, number 1, number 1, and then the one number 10 will also be number 1. Okay? 8 fewer than x. You're writing an expression to show the situation. So 8 fewer than x. You have to remember this is the one where you got to reverse it and say, well, then that's x minus 8. Okay? Because you're saying, okay, I have this, I have x, I'm up here at x, I got to go 8 fewer than that. So it's got to be, this is your whole, this is your part, and we know subtraction is always whole minus part. All right, it says 10 less than the quotient of p and 2. Now we know that the quotient of p and 2, or at least I hope we know, that we need to write that as p over 2. You leave it in the order that it's given because it says the quotient of. So that's how you would write that. So the question just becomes, is it 10 minus this, or is it this minus 10? That's really the question. I think everybody knows that this means subtract, but what does it mean? Well, it's just like fewer than. Fewer than or less than is the same way. You're saying 10 less than this, so this has to be your whole, this has to be your part. So this is going to be part over, or not part, it's going to be p over 2 minus 10, just like that. If you had it as 10 minus p over 2, it's wrong. Okay? All right. At the bottom, I want everybody right now to go ahead and put how many you got correct out of 9. So correct out of 9. If you need to pause and get those counted up, that's fine. I'm going to move on to the back page. All right. This is also learning target number 1. It says 8 more than the product of 12 and D. So when I see more than, I know that means add. I know that 8 here, that's the number 8. And then I see the product of 12 and D. Remember, I'm not going to accept 8 or 12 dot D or X, 12 dot, or I'm sorry, 12x D. I'm not going to do that. There's only one way you can show me multiplication of a number and a variable, and that's by putting the number first. So it's 8 more than that, so it's going to be 12D. We write it just like that. 12 is the coefficient, and then there's no space there, plus 8. Now, this is one of these special circumstances where I will actually accept a second answer because of the commutative property of addition. I'm going to write that up here so you can have it. Commutative property of addition, which states that 4 plus 3 is the exact same thing as 3 plus 4. You can flip the order of an addition problem, and it won't hurt you. So having said that, I will also accept 8 plus 12D. Okay? I will accept either one there. Okay, the next one is kind of a combination on number 11 as far as learning targets go. It's learning target number 5 and number 6. So I'd like you to just go ahead and put a check or an X for both of them, okay? Because realistically, it kind of covers both of them. So I'll get my highlighters all ready here because we're going to be simplifying. So before you can start simplifying, you have to get them. You got to get rid of parentheses. Like some people, this is wrong, so don't write this or anything. But some people think, well, I got 6M and I got M. Put those together, that's 7M. And then 3 and 4 and 2 and 5, put those together, and then you get 3, 7, 9, 14 plus 14, and that's just not, you just can't do it that way. It's not, it doesn't work that way. That would be breaking PEMDAS. You'd be going inside parentheses and just taking numbers away. The first thing that you have to do here is you actually have to expand it or distribute it. Now it gives you it gives it to you in the directions. If you forgot the word expand, everybody draw this little arrow over here, and I would like everybody to write distribute. That's all it means. You're expanding it, aka you are getting rid of the parentheses. So what I'm going to do is I'm going to take this 3 right here and I'm going to distribute it through there. Okay, and I'm going to do the same thing to the 2. That'll get rid of my parentheses. 3 times 6m would be 18m plus, not 4, but 3 times 4, which is 12. Bring down this plus right there. 2 times m would be 2m, plus 2 times 5 would be 10. Now that I got the parentheses gone, now I can start looking and saying, okay, I got 18 monkeys there. I got 2 monkeys there. All right. And then I have the constant 12 there, the constant 12 there. I can put those like terms together. So I see 18m and 2m. That's going to give me 20m plus 12 and 10. Put those together, and we get 22. Now, this is another one of those situations where I will accept a second answer because of the commutative property of addition. And I will also accept 22 plus 20m. Now, for those of you that remember, I know I mentioned in class that I want you to always try to put the variable term first. Not that it's important this year, but it will be going forward in your math classes next year, and then especially in 8th grade. Okay, let's go on to the next one. The next one is learning target number 6. Okay, you have to factor using the GCF. So that's important because there's a lot of answers here. Sorry. There's actually quite a bit of answers that you could actually have on this, because there is a lot of equivalent expressions to that. But because the direction specifically mentions using the greatest common factor, you had to find the greatest common factor. So if you don't know what the greatest common factor is, you'll have to go back to chapter 1, and then you would have to do your trees. I'll even do that part right now. 4 and 5. Some of you might know the GCF already, but I'm just going to do it anyway. If nothing else, it's a good refresher. Remember, you break these things down all here. 2, 4, and 2, 2. Okay, you stack them up. That's going to be 2 times 2 times 5, and 2 times 2 times 2 times 5. And then you find what they have in common. They have a pair of 2's in common, a pair of 2's in common, and a pair of 5's in common. So remember, we use one of those from each one, and we multiply. And when you do that, you actually get 20 as your GCF. So remember, when you do this, I think I might have wrote the learning target out here, but I'll do it again. Number 6. These next two will both be number 6. Okay, when you do these like this, you're trying to turn it into something like this. The opposite of what we're going to do on this one, where you're just going to expand it. We're trying to turn it into that. So we know the GCF goes there, and that's 20. And then we ask ourselves, 20 times what would give us 20R? Well, if you put 1, that's wrong. Okay, that's the mistake a lot of people make, because 20 times 1 isn't 20R. It's 20, but it's not 20R. There's a difference. Okay, the next thing I will not accept, is I will not accept 1R. Okay, that is not how we write 1R. There's only one way we can write 1R, and that's just to write R all by itself. 20 parenthesis R, and then what would I multiply 20 by to give me 40? Would be 2. And that is your answer. That is the answer that I will accept. You did not need to have this work right here. No, you didn't, because some of you probably did it in your head, and that's fine. But if you had something like this, like that, even though if you distribute that, it would give you 20R plus 40. It gives you this. It's definitely equivalent. The problem is that is not the greatest common factor. I gave you specific instructions to use the greatest common factor. Okay, number 13, now you're going to be expanding this. Remember, you may want to write this word out so we know it. That's the same thing as saying distribute this. So we're going to take it, we're going to multiply it. We're going to get 18H plus 3 times 7 is 21. And that is your answer. Okay, number 14, this is going to be another one where it's 2 learning targets. It's just like the one above. It's going to be learning target number 5 and 6. So do a check and X for each one of those. Okay, so the first thing we're going to do is expand it or distribute it, just like we did above. This would be 14n plus 16 plus 5 times n would be 5n. 5 times 1 would be 5. I have a lot of people that just leave it as 1. Just be careful with that when we come to the summative. Okay, now we're ready to combine the like terms. So I used m's an awful lot, so we'll call them something else. We won't call them monkeys, we'll call them milkshakes. Or actually, they're n's. Okay, that's just a really terrible N, evidently. Okay, we'll call them nachos. I have 14 nachos here. I have 5 nachos here. I can take those nachos and put them together. Okay, and then we know that constants, they can always be put together because they're just numbers all by themselves. So I'm basically going to be doing this and this put together. So 14N, 14 nachos and 5 nachos, that's going to give us 19 nachos. And then we're going to add those constants together. 16 and 5 makes 21. And that's your answer. Okay, number 15. This is learning target number 3. Again, I'm going to be very picky about the work that I want done. If you just simply wrote the answer and just have the answer down on your paper, it's incorrect. You know that I need you to take this algebraic expression and turn it into a numeric expression. So the first thing we're going to do is make it 2 times 4 plus 10 plus 4 plus 6. And then we're going to write PEMDAS. You didn't have to, but if you're not good at it, please write it. There aren't any parentheses. There aren't any exponents. There is multiplication or division, which is that. And then it's 8 plus 10 plus 4 plus 6. Done with multiplication and division. Now we look and say, okay, is there any addition or subtraction? Yes, we're going to go left to right. We're going to do one step at a time. 8 plus 10 is 18 plus 4 plus 6. 18 plus 4 plus 6. We're going to do this and make that 22 plus 6. And we're going to finish it right there with 28. Okay, so you had to show your work here. One step and rewrite. If you didn't show it, it is incorrect. I think I've made myself pretty clear throughout the chapter how I want that done. All right. Kyle completed 14 problems for tonight's homework before dinner, and he completed P problems after dinner. Write an expression to determine the total number of problems he completed. So let's imagine this line right here is representing lunchtime. We know that he completed 14 before dinner time. This is dinner. And then he did P afterward. If we're trying to figure out how many total he did, we know it's going to be adding, right? Not multiplying or dividing or subtracting, adding. Okay? So we know it's going to be 14 plus P, and then I would also accept P plus 14. This is learning target number 8. Once again, it's not something we covered in a video, but they're pretty easy, I think. All right, let's go up to the top right now. Oh boy. All right, this is going to be learning target number 5. The triangle has side lengths of 3m plus 1, so I'm just going to write these in. 3m plus 1, 4m, and 7m plus 3. Write an expression in simplest form to represent the perimeter. Okay, so this is a little different way of looking at this chapter, but we have to know that perimeter is when you add up all the sides. So what we're looking at is we look at 3m plus 1, that's this side length, plus 4m plus 7m plus 3. Okay, so now we have 3 milkshakes. I can finally use milkshakes now. And we have 4 milkshakes, and then we have 7 milkshakes. Okay? And those are all like because they have the same variable and all that, just like you guys know. And then we have our constants, which we know are always like terms. The constants are 3m plus 4m makes 7m. 7m plus 7m equals 14m. And then 1 plus 3 would give us 14m plus 4. So anyway, you will have one of these on the summative as well. It may be a different shape though. It may be a rectangle. It might be a pentagon, hexagon, octagon. It doesn't matter. Perimeter is very easy because all you have to do is add up the sides. So if you had a rectangle that was 2x plus 3 and then 3x, and I asked you to find the perimeter, you would say, well, it's not just 2x plus 3 plus 3x. That's the mistake that people make. They say, okay, well, 2x and 3x makes 5x plus 3. Why is that wrong? Because that is just the distance from there to there. Okay? So that's just halfway around it. The perimeter is the entire distance. So you got to remember you have to add all those. Okay, so then that's going to be 2x plus 3 there, and 3x. And then actually what it would look like would be 2x plus 3 plus, sorry, this is so sloppy, 2x plus 3 plus 2x plus 3 plus 3x plus 3x. And then you would combine your like terms, right? And then these would be like each other as well. Okay? All right. So you will have one of those on the summative. I just want to make everybody aware. All right, number 18 has been a highly missed question. Always is. And the reason why is because people don't show their work. They simply say, okay, well, 2 times 4 is 8. 8 to the third power is, I don't even know what that is. But regardless, it's wrong. This is why I make you guys show work. Okay, this is exactly the reason right here, because this question, these types, people try to do these things mentally and it ends up messing with them. The first thing you do is you take the algebraic expression and you turn it into a numeric expression. If you didn't do it, it is wrong. Okay, so we know that does mean multiply. That would be 2 times 4 to the third power. The reason it was wrong if you went ahead and did 2 times 4 is because if you did that, you are technically breaking PEMDAS, aren't you? Because you are doing multiplication right there before the exponent is done. And you have to do the exponent first. So you have to do this. When you do 4 to the third, you actually get 64. And then 2 times 64 is going to give you 128. So there's your tornado. Yes, you had to show it, regardless of how basic it looks. You guys know that this is what I want. So if you didn't have it, it is incorrect. This is learning target number 3. Okay. Now we'll go on to number 19, which is going to be one of those, just like the ones before. It is learning target number 5 and 6. Okay. So the first thing you're going to do is distribute these, just like usual. Okay. 3 times x is 3x plus 6 plus 2 times x would be 2x plus 2 times 12 would be 24. Okay. When you do that, now we're once again ready to combine like terms. You can see there's quite a few of these. This is like the biggest thing for this chapter, in my opinion, is this. This is what's really going to apply to next chapter and then your future math classes as well. Okay, so we know the things in orange there. We're going to be able to combine those x-rays or those x's. 3x's and 2x's, put them together, you make 5x's. Constants can always be put together. 6 and 24, that's 30. So there's your answer, 5x plus 30. And because of the commutative property, I would also accept 30 plus 5x. Okay, so give yourself a check or an X on that. All right, last one here. And now this is going to be learning target number 4. Okay, now as you can see, we only put one of these on here. So, but here's what I want you to do. We are going to grade this as if it were 4 separate points. So basically, if you want to think about it this way, this is going to be number 20, this is going to be number 21, this is going to be number 22, and 23. Okay, that's how we're going to grade it. Okay, so basically you're going to have 4 checks or 4 X's on learning target 4 for this. All right, so to recap here, terms, that's anything separated by an addition sign. So when you're listing out your terms, you're just going to list them out as X. If you put 1x, it is wrong. 6 by itself is a term. X, got to put it again. Even though it's already there, you have to put it again. 3x, term. 10. Those are your terms. Okay? Now we're on to like terms. Now I'm going to do the highlighting thing that I've been doing this whole time. I see x, I see x, I see x, or I see 3x, sorry. I know those are like terms. So what I'm going to do is I like to put them in parentheses just to show grouping. I know that all of these are like each other. Okay? Let me change colors here. I know that the constants here, those are like each other. So again, I like to put them in parentheses because then you can just see what you're talking about. Those are like each other. These ones are like each other. And then the ones with the x variable in them, those are also like each other. Okay? So then there you go. If you put ones in front of the x's, it's wrong. Okay? If you didn't put parentheses around anything, it's wrong. Because you'd just be making a big list. That doesn't help you identify the like terms. We know they're terms, but just the ones in green are like each other. Just the ones in pink are like each other. All right? Now we'll go to coefficients. I was getting some questions on the test about coefficients. Okay. Now remember, a coefficient is the number in front of a variable. So if I had 3m, 3 is a coefficient, which is all good. I would not include m in my coefficient list, though. Okay, so it's just the number in front. The problem comes is when it's just m or it's just x, because technically, at least it appears, there isn't a number in front of there. But as I went over with you during class on numerous occasions, there is absolutely an imaginary 1 there. So here's your coefficients, 1, 1, and 3. Those are your coefficients. If you put it as 1x, 1x, and 3x, it is wrong. Okay? It is incorrect. If you put it as x, x, and 3, it is wrong. Okay, you had to have it exactly like I have it here, or it's wrong. Okay, and then finally, you've heard me say the word constant about 50 times on this video so far. Constants are any number, just a numeric term all by itself. And in our problem here, those were the pink ones, or purple, or whatever color that is. So I know that it's going to be 6 and 10. And that's it. Those are your constants. And you actually didn't have to simplify it on this one. If we were going to simplify it, I hope you would realize that, well, it's 1x and 1x makes 2x, plus 3x would be 5x, and then 6 and 10 would make 16. That would be the simplified version of that expression. Okay? So this test is going to be out of 23. I'd like you to flip to the front and put what you got out of 23 real quick. So it's out of 23 points, and that's it. So just put your number correct out of 23.